Let's continue the system design concept. And last session we talked couple of architectural style, the way we can build our software systems. And so initially we talked about the monolith, then we talked about the modular monolith, then we talked about the microservice architectures, and now we are going to talk one of the key architectures where known as a event driven architectures. So many in our applications we need a kind of our system be responsible for the sudden change in any part of the components, any part of the system, right? So might be case. So whenever you are building a couple of microservices, yeah, a couple of systems, and they works independently. That's good and nice. Okay? But sometime I want to do or perform set of actions if something happened on a specific server or something change happen in the we are another modules, another service, or want to perform some kind of actions, some kind of activities, right? So in this scenario, let us for example, in the class lots of students are waiting. Okay, so whenever teacher come, they are start teaching. That's good. So now notice each and every students are ready to listen. Okay, and be attention. Questions are teacher, whatever the teaching on the boards, it's okay. Everyone are listening. Might be someone say, hey, anyone ask questions? Or each and every student be attentive, be responsive to reply anything questions asked by the questions. So in real life, many places you find some event, some change happen, and those changes, another people, another system, another applications must be responsible. And in the real life scenario, many places we find lots of event happening. Event means you can say event have a lots of context. Okay, but here events in the case of software designing, event means in whole system, whole enterprise applications, any change happen, anything, anywhere, sudden change, something happened, those happen are known as a event. Here any parts of the systems, something change happen, and on those changes I want to take some action. I am really interested to handle those events. Those changes we can say event. Every changes you cannot say event, but the particular changes where we interested to take some decision, right? So that is the case event. So we are going to discuss basics about the event driven architectures. So as you mentioned, this is also one of the approach where these architectures in use in the many parts of the my system, because notice in the microservice architectures we are building a small independent multiple applications. Okay, so each applications depend upon the customer requirement, have a different nature. So might be each application, different application had different kind of a style to implement, different kind of patterns they can use, different kind of architectures they can use, right? So in the softwares system designs, this is not thumb rule, hey, this is only one architectures and we can use. That's not, because depend upon the natures of the customer change, customer requirement, we have to select different software design pattern, architectural style to meet the customer need. So might be you find these the microservice architecture, event driven architecture can use both in the same application. Some part of the our application required to handle the some unexpected or expected some event or some changes, then we have to respond. Generally all the kind of your good example confirmation notifications, these are the event driven activities. Hey, let's you order a particular go to the e-commerce website and you place a particular order. So particular order is placed, this is the one event, and now go to the payment system. Payment system get notification, hey, particular order is placed, let's you collect the payment. And once payment done, payment system say, hey, I done payment, let's start the shipping. The shipping process can start. The shipping microservice take one notifications from the payment system. Payment system get notification from order system. So somehow these the independent microservice are also need to communicate via the event. This such communication known as a asynchronous communication as well as, right? So here this architectures, this is the event driven architecture, is software architectural patterns that revolve around the productions, detections and consumption of event. Means something first, some part of my system, some change, something event, some message, some logs are produced or change by the system, change by automatic, change by human driven, change by nature, anything. So somehow in a particular part of system, some events are produced, some events are generated, and our other part of the systems have a capability to detect, to find out, hey, something event is generated, maybe some log generated, maybe some change happen, some request happen. So first things, events are produced by some component of my system, some part of my systems. Okay, and second, different part, different module, different applications is responsible to detect them. And thirds, we have to one application, if we detect some event, then we can take some actions. So we can decide, say, I am going to consume this event, and according to the event nature of event, we are going to perform some specific task, right? So here in this event driven architectures, the event is the very you can say significant thing. Without any event, without any change, event driven architectures are the components which are ready for detection, which are ready for consumption, cannot do anything until our event is not produced in some part of my systems. So here event is significant change in the state, or can maybe sometime occurrence that is of interest to the system. So you notice in the our system designs, we have a lots of component, and each components works and lots of changes happen. So might be we are not interested to every changes, but some specific changes, some specific state change, I want to take some decision. So those specific event where I have to take some action, that is known as an event. Generally these event driven architecture are really very helpful to implementing real time processing of an event. So let us good example, stock market. Every second when market open, lots of users are doing something, lots of events are generated. So near time I want to collect all the data and produce some kind of a similarly lots of places you need some real time processing, and where the lots of user they are communicate to each other, where asynchronous communication also you want to establish. This event driven architectures play very roles. Event driven architectures say our system is not like a predefined patterns. Okay, let's in the systems you have a design some component 1, component 2, component 3, component 4, component 4. So all these components are work independently, but there is no any guarantee which systems is working when. Maybe this have got some kind of event Accordingly, this system can behave something. Okay, this system can behave something. So something depend upon the something happen in the system, some change happen, some event generated, then other part of the my system, other component is start doing something. Okay, due to this, these sometimes say this is the asynchronous communication between the different microservices or different component or different part of the my systems. Okay, many places you know the event is happening. Let's if you are in office, okay, and maybe you go to the doctor appointments, lots of people are just waiting for the doctor appointment. Doctor is the treating something, and we have a receptionist also. Hey, doctor, ring a bell. Hey, then receptionist take action. Hey, what kind of a ring bell, and for which patient I have to send something. So lots of places where the doctor is doing some his activities. One, he check the every person and they ring the bell or press the some button, and those button our receptions are specific, the action is taken by someone going to detect, right? So here the objective of event driven, one part of the system are changing something, want to do something, but they are not going to. Other part of the system, other modules, other microservices are going to take some actions. Okay, the here objective is that the lots of requirements, lots of functionality we are not going to expose to done by only one modules of the system. Objective is that we have a decouple our system, break out the system is a different part, different component. So our one modules, one service is doing some specific work, and other related activities just delegate. Hey, let's you do the sometime task delegations, work delegations also consider here the event driven architectures. So these are the some basics concept whenever you are going to understand the event driven architectures. So first about the event, which already discussed, event represent any state change. What do you mean state? State means let's this is the one object have some set of attribute and value, and someone go and change the particular value, maybe state change, temperature change, weather change, like a continuous IoT device data you're receiving, all are the event you can see. So something change in a system, and those changes our other part of the system is very interested to take some action, and this event can be continuous basis, regular basis or irregular basis, but sometimes random. So event can be generated the multiple way. Some systems or some events are continuous basis are generated, like our any kind of IoT devices, like continuous, they are sensing the temperature and sending, like the aeroplane system, lots of sensor devices are detecting some data and sending, all are considered an event. Like weather information continuous, our GPS information, GPS track system, these all are the kind of suddenly track information and sending to respective devices. So all are considered events, and some events are continuous event generated, some are occasionally generated, some are randomly generated. So event can be sequentially generated, plant generated, or some occasionally generated, or some kind randomly, anytime a particular events can generate it, right? So for all these events, which the part I'm interested as software engineer, we have to decide something. So as we discussed, whenever we consider event must be someone produce. The first things, someone going to produce event. Let's see, this is the event, this is the producer is produce one event. That's good. So someone we have to decide. So someone consume this event, right? So we have an event provider. Another component is the event consumer. And once you know consumer, after that they decide, hey, some task required to complete it, maybe some event handler. And whenever this one event producer produce event, another event consumer consume events, how they are communicate to each other, they need some communication channel. Okay, already we know we have a couple of event communication channel, like directional, bidirectional, synchronous, asynchronous, like which protocol. Similarly here, our one important part are the channels. Channels may be synchronous or asynchronous. Generally in event driven, we are using the asynchronous communication. Asynchronous communication, that means this message is generated by producers, are not directly consumed by the consumers. This message go in the intermediate places somewhere, and once this consumer are just going to read from the some specific designated places, those intermediate place or intermediate software or intermediate components, sometimes we say MOM, message oriented middleware, or sometimes say it's a broker. So here the main concept: events, event producer, event consumer, and the channel asynchronous channel, and event handler, and one part is the intermediate component or software or placeholder where the producer going to produce the messages and consumer going to consume the messages. Like a good example, whatever the messaging system, like a WhatsApp message or any kind of message you send, go to the middleware server. Like when you send an email go to the middleware server, and from the middleware server we read the message. Generally email, chat, messages, all are the asynchronous messages. Okay, so these are the basic concept: event producer and event produce, event consumer and event consumes, and one is the middleware where event is produced by and from where the event is consumed by the consumer. Okay, and once event consumer consumes, they are delegate our work. Hey, event handler, let's do processing, let's do this task. So these are the basic architectures which we discuss, like a event producer, event channels, event consumers, and event handler. These are the basic components of your event driven architecture. So one is your event producers, one is your event consumers, and another the middleware software that are going to take the communication, asynchronous communication. Producer produce event here, and consumer consume event from the here. Both are the asynchronous. They produce event at a particular A point of times, and maybe B point of time later another consumer come and can consume the messages. So this is a very event driven architectures where the one part of the mesh systems are going to generate the event, produce the event. Another part of the mesh systems, maybe my system and other systems, are going to consume them. Both are communicated via the asynchronous channel of the communication. That means we are using the some broker or middleware concept, right? So this is known as a event driven architectures. And nowadays lots of this channel available, like if you know, you can say the medium through which the events are communicated by the producer consumer. Maybe you can use the messages. Sometimes you can send message queue, or sometimes event stream or webhook. All are the communications protocols or channels available where the events are consumed, are produced, happening through these channels, right? So let's talk some use case scenario where these event driven architectures are fit, because anything whatever we launch, we have to know which use case, what is the scenario where this architecture is fit better, fit best other than architectures. Okay, so as I already discussed, any real-time analytics applications are really nowadays use, like all kind of applications where you are going to build near-time analytics. Right now, where analytics means you are going to understand the lots of continuous events or system generated data. You aggregate them and summarize them. I want to get some clear analysis of the huge generated data. So here, for those scenario, event driven architecture is very useful for the real-time analytics. Okay, where the events or the logs or the data continuous generated by the systems, and on those huge volume of data, our analytics persons or business analytics person can just view the high level insight and extract the real time information from those scenarios. Similarly, I mentioned the all the IoT device application, IoT device application. IoT device application is the device that are continuously generating data. Like a good example, air flights. Whenever air is going continuous, they are generating our data, our position, our GPS location, height, everything continuous. Our they are generating data. Like our weathers, continuous weather data is going to collect whether meteor cloud the meteorological department. And similarly, maybe your the sensor data, every place nowadays you can say lots of devices that continuously generating through the help of sensor sensing data and sending right now. So these are the wherever IoT device you are generating lots of data, and our application receive this, and they after that you want some kind of a real time response. So again, the EOT event driven architecture play very roles. And as also discussed in the financial market, like stock market, where the continuous whenever market open, lots of user doing the transactions, selling, trading, performing the trading operations, and those times these finance transactions also considered as an event, and those are easily handled, taken care by the event driven architecture. Even nowadays, lots of we are playing the gaming system, multiplayer gamings. Multiple peoples are playing a games. So each they are generating event, and those are communication happen. Those kind of scenario also event-driven architecture play very significant roles to the implement. So like gaming system, online gaming system, or multiplayer gaming system, financial market, tradings, and IoT devices and real-time applications. In this scenario, this kind of you can say event-driven architecture play a very significant role, right? So let's consider some kind of once we are going to implement this event-driven architecture, our systems get these kind of benefits. Like our system are integrated, communicated with each other via loose coupling. So one of the software design principles, loose coupling. By default, our systems implemented with the event-driven architectures. So event-driven architecture is one of the key features. Your systems have a very loose couple relationships, right? So they promote loose coupling. And what if the loose coupling, our individual modules or individual software components are easily maybe add, modify, replace, delete, because they are not directly tightly coupled with the entire system. So our entire systems, ecosystem, software systems are very flexible, you can say. Okay, so you can say scalability, because your systems, all the modules, all the components are very loosely coupled. So lots of benefits by default we can get. Your system is scalable. Sometimes you can add more servers, more the instance of the server. Our system become flexible. We can remove the instances, we can add new server, we can replace them, right? And they are by default discuss the real-time processing, where our systems, one part of the system continuous generating data, generating events, and other part of the system we want to do process them, analyze them, summarize them, and give some quick overview by the business management, the real-time processing. This applications also very well. And the last, not the best least, the fault tolerance. By default, if we are implementing this event-driven architecture, some level of fault tolerance can be. So generally, all the fault-tolerant applications, particular event happen here, particular system fault, or CPU high usage, or memory is a high number of users. So those scenarios also track and take action. Hey, this particular CPU is going high usage. Let's start the new server. This server is going to some hardware issue. again let's replace the new server. So such kind of fault tolerance as an event, and that can be play a very crucial role to handling those failure scenario, fault scenario. So in those cases, our event driven architecture can play a very significant role, and by default our system become a scalable, maintainable, scalable due to the loose coupling of the nature of this event driven architectures. Even these systems, again say this designs event driven architectures is not fit to everywhere. You cannot say, hey, I can use the event driven architecture and my whole requirement of the customer I can implement to the same. You can do, but this is not suit for all kind of requirements. Let's be carefully think which part of the systems is fit, where this system is not fit. There is some kind of a drawback, limitation, challenges as well, as we should aware whenever we are going to introduce event driven architecture in my system. Because whenever we are going to add more and more layer, more and more the business logics, so by default event driven architecture introduce some kind of a complexity in the case of your designing and implementing, especially in the large scale applications. Okay, even these are the very challenge event driven architecture application about the debugging. Your software developer or engineer cannot debug application where there is no sequence of flow, where our which line of code, which method invoke, they apply the debug point, because the events are generated this part, and after generating this part, okay, this is the one system. Let's say engineer going to debug here, and from here the system generated. Now another system is going to start playing something. Okay, so here our debug point is stuck because another system take place and doing something. So here the developer feel uncomfortable to debug such event driven architecture applications. Okay, and even sometimes you also face kind of a challenge event ordering. So multiple system, one, system two, this is also generating event, this is also generating event. So which order we have to generate system? Okay, so somehow we have to make ensure, if some places like financial transaction, we have to keep extra care to ensure that every orders, every transactions happen a particular order, so that we cannot lose the atomicity and consistency problem in the financial domains. Okay, so for that, this is sometimes you feel we have to put extra effort to ensuring the event ordering happen. Somewhere there is no problem, any order you can process the event, but somewhere you want to ensure all the events must be processed in a particular order. Okay, so those scenario you have to ensure some level of additional step designs we have to place, right, basically in distributed system. Similarly, sometimes we have to also ensure that we are not going to process or receive same event again and again and again. The duplicate event processing also kind of a challenges. We have to ensure that unnecessarily you are not going to process the same duplicate data again and again. That's lead maybe problem. Let's say same event you can generate consume by the multiple times. So you can say, hey, hit count is the 3, but really hit count is the only one event generated hit count, and you can consider it 3 times. So that's the challenges. Sometimes while implementing the event driven architecture, we have to ensure that the nature of business somewhere that is not so problematic if you can consider the event duplicate event as well as, but like a financial market, like a real analytic system where you cannot compromise the false data. Okay, so such sometimes we have to be carefully ensure that we are not going to generate or process handle duplicate data again and again. That's maybe lead your business incorrectness and potential bugs or error in futures. And similarly, whenever you are sometime you face the challenges about the scalability, because here while event driven architecture here is scaling your application horizontally, so they have a limited number of events, because accordingly you have to add more and more event handler, because new horizontally new server, you add new server, each they are going to generate the system. So accordingly, our event handler, whichever maybe one or two component, we have to also need to scale. So be carefully while the thinking event driven architecture. They have lots of advantages, lots of benefits, but same times they have some kind of challenges and limitation. We, at least as an engineer, system design engineer, we should aware, we have to be plan for those. And to achieve these kind of event driven architectures where a producer produce messages, okay, produce messages, and our consumers are going to the consume messages. So lots of architectures, the technology available nowadays, they make our system designer engineer's life very easy. Lots of open source, non-open source, cloud provided, the event driven architecture platforms available, like a very heavily used the Apache Kafka. They are very popular event streaming platform for the building event driven architecture system. Even Apache Storm also distributed real-time computation for the processing, right? Even you would go to the cloud provider, AWS Lambda also provide the serverless computing platform for building the event-driven architectures. Even the Google Cloud also have a meaning like a similarly event-driven system to accessing PubSub, Google PubSub architecture. Similarly, your Azure also have a event grid. They are managing events. So lots of cloud also provider is providing the event-driven platform to you, and even open source technology you can use to implement event-driven architectures. And if you look the lots of applications are already built with the help of event driven architecture. The technology list is very huge. I'm going to just talk couple of them. Uber is a good example where lots of driver customers requesting for rider, driver is racing to the all are the events, right? Let's for example the events from the driver, rider, payment systems, all are the real time required, right? Let's say you are suddenly booking a one ride, so suddenly one ride event generated by the you, but because the system don't know which user which times they are going to book the ride, the ride book is a one event for the Uber system. And similarly the driver can receive one event, hey, one ride is booked by my customers. Oh, this is the one event. Let's see your ride continuous base, our user want to track, hey, where is my driver when they receive. So we have to Uber application, so the driver current location, yes, driver is moving, and once user receive his destination part, at that time, hey, continuous say, hey, driver generate our one event, hey, ride is completed one event. Again our payment processing system, hey, generate the bill for this customer. Continuous payment system going to generate one event, hey, let's generate the bill for the customer, and instantly user receive, hey, this amount we have to pay. Again you pay the bill. Uber system say, hey, I received the payment, give the confirmation to driver, hey, event payment is received from the customer, ride is completed. So all the places here, from the driver perspective, event perspective, payment system and system, all are the communicated real time with the help of event driven architectures. Similarly, if you talk about the Netflix also use the event driven architecture to process the event of user interaction, such as a video playback, rating back, right, or something. Once video playing going on, you go and apply the some rating continuously. You generate one event, I want to rate this video, or I want to play back, I want to go forward. So all kind of events suddenly user generate. Maybe our Uber system, please be ready to generate those events. Similarly, LinkedIn also use the event driven architectures to process the like hey, someone going to update the profile, you inform the lots of notifications, or maybe the number of active connections, recent post, so lots of things in the LinkedIn. And similarly your here DNB also use the highly event driven architectures, while the booking request receive, payment receive, or maybe host notification and receive, lots of. Okay, similarly Google also use the event driven architectures, number of click, number of query, number of sends by the user search. So you can say in the our real industries, many places this event driven architectures playing a critical roles. So we should aware what are the architectures we are playing, not just for theory, but really nowadays these applications, these architectures are used by the many applications. Okay, and nowadays due to the microservice architectures and many places, these two are work together and fit meet the many customer use case and scenarios. So the one of the basic use case, if a microservice environment you are building multiple systems and you want this system to communicate each other, the communication should be loose coupling. That is the event driven architectures play a very significant role to make asynchronous communication between the other microservices. So here event driven architectures are using the microservices architectures to enable communication between the services, like asynchronous communication. Okay, similarly our service discovery, all the service discovery also use the event driven architecture to find, to search, to communicate with other services. Okay, with some service compositions also one of the benefits, where event driven architecture say composing services is composed together and make one kind of a complex workflow, where you can notice let's go, this is one complex workflow 1, then done 2, then done 3. Let's get passport processing system. First user submit his all the passport details, and then just once passport verification details some, hey, inform to the nearest local authority to verify the contents. One nearest location authority verify, let's go to another agency, verify the risk rating, financial details, and then go to the generate the. So here the some complex nature of like a financial market where approval required, where the very complex nature of application, you want to make a very streamline all the processes, where you can decouple the system, bigger chunk of complex flow, you have break down the different system microservice architecture, and now these microservices architectures are communicated asynchronously with the help of event driven architecture. That's help us to design such complex systems workflow in a very simple and simplified version using the help of event driven architectures. And these are the basic you can say architectures. So as mentioned, one part would be your message producer, one part would be your message consumer, right? So anytime any system, maybe this system or this system or this system, n number of system can just generate system. So they are generating event, generating logs, generating messages. They are not directly go to the consumer, they are going to the somewhere middleware server. Middleware server is the your broker or message oriented middleware, and this is the now any number of can be subscriber, maybe dashboard, user, administrative, public, customer, mobile application, lots of notification you can receive. Okay, like very notification is a good example of event driven architecture. You get the notification, message notification, WhatsApp notification, email notification, hey, your order is placed, here your order is the shipped, hey, your order is in progress. So these are all are the event driven messages. Okay, so these are the and this the message broker or middleware, you can say this is also very key role play by our message broker. The message broker say, or you can say MOM, message oriented middleware. This is the basic concept of the message oriented middleware, and message broker is just the implementation of the MOM. So lots of in the previous early days you are talking about only the message oriented middleware. Nowadays the lots of open source and project and cloud provided project available as a message broker. Okay, so message broker is just software components that enable messages passing through different components or services. Okay, and that's how the asynchronous communication happen. And these are the also play intermediary place are software component where message producer produce and consumer consume, and they allow to async communication between the other system. So they are make us our multiple part of the system are decoupled, are communicated with the asynchronous fashion. And if you talk this communication, asynchronous communication also can be two-way. One is the point-to-point communications. So one communication, hey, I am one person sending a message and you receive the message. Sometimes it's a point-to-point. Hey, this is the one producer produce message, go inside the queue, go inside multiple messages they are producing. Once a consumer up, consumer going to the consume message. This message, again this message, again this message, again this message. So this message is not consume another message. Similarly, another message consume by this. So they are using the concept of queue. All the messages are put in the queue in the middleware, and once consumer is ready, they are going to read, hey, this is we have to receive message 1, receive message 2, receive message 3, receive message 4. So all the messages we can receive. So sometimes say point to point are the queue based communications. So here from the between the producer, this is our producer and this is the consumers, this is our middleware. Middleware is the implemented as a queue concept, right? The queue. So all the message generated by this producers are going to just store in the queue. Next new message is stored in the queue, new message is stored in the queue. So now let's our consumer, our cup consumer consume this message, then consume this message, then consuming this message. The in way communication happened asynchronously. So sometimes a point to point or queue based message brokers are communications, and sometimes you have a pub sub, publisher and subscriber kinds of a concept where, so this is the not the queue, this is the concept of a topic. Topic means, hey, this is the only one message sent by you and you are interested this message in either the consumer 1, consumer 2, consumer 3. Let's say like weather details. The weather details can be received by the A department, maybe messaging social media, maybe our mobile update, or maybe device update. So different department require your weather information. So you have the multiple consumer are interested such information. So where means ki publisher just publish one message and consumer going to the consume. The very good example in early days like our radio systems. So notice our radios are just producing news or informations, and lots of transistor, lots of people can interested just tune the particular bandwidth and they are consuming this message. This person also consume this message, they also consume. So anyone going to tune his radio or the particular frequency, they are going to receive those messages. So here somewhere the particular informations you want to broadcast, you want to say, hey, this message anyone want to interested, they can receive. So such the communication on a publisher and subscriber architectures, and there is a concept on a topic. So nowadays almost all the, you can say, cloud providers or the Kafka, they are using the concept of topic based communications. Here means they are allowing one messages are consumed by different consumer as well as. If you want one-to-one, they apply one-to-one. They want to one-to-many, they can one-to-many. So such types of majorly, if you look the message broker, they have a different kind of, you can say, they provided the communication, but majorly these queue based are topic based. Queue based means one-to-one, you can say, one message sender and one message is receiver. Okay, one-to-one communication generally happen, and sometimes you want to say one message is sent but consumed by the multiple consumer. So one-to-one or one-to-many relationship, you can say somehow. But these are the two most used model, you can say, nowadays as a message broker provider or MOM. That was the point-to-point, point-to-point communication, or pub and sub, publisher and subscriber kind of communications. And for that, if you look we already discussed lots of open source available. They provide such the message broker implementation, and similarly you can go with the cloud provider as well. As if you talk, the famously use the Apache Kafka and RabbitMQ, ActiveMQ. So all these are the kind of broker middleware server. They are providing this basic facility where the two systems are interacts or communicate to each other via asynchronous channels. And if you want to go to using the, nowadays lots of peoples are using the cloud services, and nowadays cloud providers already providing event driven architecture platform to you. So like AWS provide the simple SQS, simple queue based services, okay, or similarly or Google also provide the cloud platform Google pops up kind of capability services to you. Similarly Microsoft also allow the your Azure service bus kind of a broker system where these facility the multiple events are generated by the one systems, and other part of the system they are going to consume them, they are going to the process them, they are going to the do some tech action. So these are all are the things, and if you look the lots of reference documents available, just you read out whatever we discuss, everything, all the big kind of service provider, maybe Amazon or AWS or talk everywhere you can find. So whatever the discuss happened, this is a mention here. Event driven architectures are Amazon also support, and lots of kind of architectures or document you can find here. Notice this is a very high level event driven architectures. For example, our AWS have already in this place. So here notice the event producer, like maybe producer by the your retail websites where the consumer can make any order on the card. Say this login to the systems Amazon, and Amazon already provided the every person one card, and you go to select a specific product and add it to the card, maybe one product, two products, and just place your order. The placing order is the one event, new order is the one event. Okay, similarly might be you can place from the websites. Okay, you can go ask any quick questions, or maybe particular SOP sales of point of sales from where the you can return some information. Okay, so event can be any forms. Generally whatever that you are doing on the AWS e-commerce platform website, okay, generally they are generating event. So because the AWS internally using the microservice architectures, lots of different components are placed here. The which components start serving your request, so they are generating one event. So somehow they are using the here the events. So they are generate one event to here. This event is subscribed a particular microservice which are interested to take action. Okay, and that is the here your event router. And lots of this is the middleware they implemented, and corresponding event consumer, maybe their information go to the database, data warehouse, application, financial, customer care, what kind of event consumer. So notice here come somehow your the system, like your the complete application, this system and this system where the information going to store are completely decoupled, not the tightly relation between to here. They are decoupled, they are just generate one event, and this is the queue filter queue decide this is going to taken care by this service or this service or this service. So somehow very good example of the event driven architectures that the almost all the you can say social media platform, or you can say e-commerce platform applications are implemented the event driven architecture. So this is a good, you can just explore this website. This is a freeware available. Just go to the Amazon and search the I want to event driven architecture for the Amazon e-commerce platform, and you found this detail, and you can read everything, what kind of additional benefit this architectures follow, from where you can start. So notice AWS also provide this kind of event driven architectures, maybe two types. One is the event bus based, one is the event topic based. As we discussed, there is two kind of major message brokers. One is the queue basis like bus, and one is the topic basis. They are also support, and for these two they have a two system. One is the Amazon Event Bridge, they are implemented, and another is your event topic based like the Amazon SNS. SNS is a simple notification service. So nowadays, if you are getting any kind of notification, message notification, email notification, WhatsApp notification, all are generally event driven architectures. They are very decoupled system. Once something happened, your processing happened, your payment received, something, you get the notification. So all the nowadays notifications services, all the kind of implemented. As a good example, you can say event driven architecture. And the AWS environment, you can maybe use the AWS Event Bridge or AWS NSS. Amazon, both have a good documentation available. Just and go explore them. But all similarly, this AWS, similarly other cloud provider also, you go to the Google or you go to Microsoft, each cloud providers are offering these event driven architectures. They are very famously are used by nowadays all the large scale distributed application for the notification and confirmation. Okay, and similarly you can also lots of reference document for you available. Just go and read out, and you find the event driven architectures for the asynchronous communication and its benefit. And they are talking this is the kind of one, you place the order. Okay, whenever you user from the mobile or you are placing the order, they are going to just one message queue and order 1, order 2, order 3, and similarly the systems are going to process them. Similarly, maybe different systems, hey, confirm, hey, this have no item available, something. This is the look like your asynchronous communication happen. Even the pub sub model, similarly, like, hey, publish model, and multiple subscriber, service 1, service 2, service 3, someone, many different application interested to those messages to interest. Okay, but sometimes one message is taken care by only one service, and sometimes same message is taken care by a response by multiple service, they interested to those information, right? So event driven architectures are lots of kind of you can say contents available in the market. Just go and read out and try to implement, because they are a different use case where you are going to use this event driven architectures are used in the microservice environment, where this is also very good concept, the Saga patterns, where if your application is distributed, now you are going to manage the distributed transaction. This is one of the major problems or challenges, how to manage the distributed database transaction in your system. So for that, this is the Saga pattern, and these Saga patterns are implemented by the event driven architectures. And these Saga patterns have two approaches. Both approaches, you can say, hey, two microservices are going to communicate to each other using the event driven architectures. So by default, maybe as discussed, you can use the AWS provide the event driven architecture, maybe SQS, SNS, MSK, all are the event, maybe the event bridge something. Lots of components AWS provide. Similarly, you can think how we can implement the Saga have two approaches. Saga patterns are very you can say nowadays in the era of microservice invention, microservice architectures, many popular you can say the terminology, what is the Saga pattern is important pattern to implement the event driven architectures, and they ensure the data consistency across the different distributed microservice. So thus the main purpose of the Saga design pattern is that, hey, this is my distributed application, each microservice is their own database, and now I want to make one level of data consistency between across the microservices. So for those scenario, how you are going to say, hey, rollback scenario, fault scenario, data consistency from your scenario, ACID scenario, those scenario we can manage by the two options Saga have. One is the choreography option, one is the orchestration option. So both you can say choreography also you can implement using this event driven architectures. Choreography orchestration, whatever issues come, hey, different kind of patterns, hey, now this is our just event generate, event are processed by this, then this, then this. So somehow you can implement. And similarly you can go with the orchestration base. Hey, this is one service, we are just apply different orchestration. Hey, this service, this service, this service, means all the service are communicated to each other. Like here, whenever services start, Saga say, hey, let's place order, the order microservice play along, then order is placed, then different microservice take an action. Hey, inventory updated, inventory management system going to do something. Hey, all are the, these are the events. Okay, these are the events, and might be sometime you need a transition between the two. So these are the like order plays, order changed, or update inventory, or inventory updated, or marketplace, or payment success or failure. All are some, you can consider these are the event. According to the events, respective microservices, respective communications can go and take place. Okay, so lots of you can say communications between the asynchronous, lots of different services you can place. Okay, so these are, you can say, lots of contents available for event driven architectures. Let's just go and explore. So the my objective is, you should, as a system designer and engineer, you should aware event driven architectures, where two subsystem of your entire applications are going to exchanging data, exchanging messages, or some activity you want to do on something event user, something event happen here, this system want to perform something. So they are not directly talk to each other. Hey, they generate even, hey, this is my one events and something I want to do, and this already subscribe them. Hey, already you so. So this information by default they are active and going to run this. Lots of system here, lots of system here, lots of system here. Lots of systems are not interested to any actions if something action here. Hey, something checkbox pattern here. So only this system is going to active and play a role. So here, whenever you are designing very big enterprise application, a very large scale application, lots of components, lots of subsystems, and here you want some indirect communications or order management or something, perform some activities. Here I say, hey, those if something happen, those code we can logic we can write here, but my system is going to again do the multiple work in only one system. So modular microservice architecture say each microservice is responsible to do only one specific business capability. This is the different business capability. Why not put it a separate microservice? Something required, I just generate one event. Hey, event is generated, let's go and you can do. Similarly, other system, hey, they generate some system and this system going to respond. So whenever your one customer requirement, you decouple in the different microservices and different services where you want to make some kind of alert, some confirmation, notification service. So generally all the notification service are communication between the different microservices. Very right place where you can think event driven architecture play a very significant role to achieve such a customer requirement, like all the notification requirement, all the loose coupling, and your asynchronous communication between the microservices, like a managing distributed database between the microservices, where the event driven architecture also play a very significant role. So you can surely understand the importance of event driven architecture in the system design. Hope this information is helpful for you. Thank you.